This video is going to guide you through the hands-on project for our database class. The deliverables for this project are going to be basically what you see here. First, we're going to create some new tables for patient visits. So our database right now, up to this point, did not include any of the tables that we had diagrammed for patient visits early on in one of the earlier projects. We're going to add those tables to our database diagram and create the foreign key relationships. It's going to connect it to the rest of our tables. Then we're going to create some stored procedures that are going to allow inserts into those tables rather than users inserting the data directly. We're going to have some test data that we're going to use to insert some data that we can play with, and we're going to use indexes with that test data. So we're going to learn a little bit about indexes in this project. We're going to add a column to the patient table. That's going to store the date modified, and then we're going to write a trigger that inserts the modified date anytime somebody does an update on that table. So if they change something about the patient, it'll put a new date in there. And then finally, we have some reports that our users are going to need that we're going to create some views for those reports so that users can see some standard data in their database. So let's get started. So the first thing we need to do is create our two tables. So we're going to right-click on Tables, click on New Table, and you're going to fill this in with some columns. So your columns are going to look like this. So we have about 7 columns here. Just note that we are not going to allow nulls on any of our columns except for the doctor notes. So we're going to allow nulls on doctor notes, but none of the other columns. And be sure you use the same data types that I used here as well. So pause the video and create this, and put these fields in, but do not save it yet. We have one more step we have to do before you save this. So go ahead and put these columns in and then come back to the video and we'll do one more step. Okay, now the next step, we have to create our keys. So to do that, to create our keys, we are going to have to highlight 2 of these fields. So normally we would right-click and just hit Set Primary, and that would set our primary key, but we don't want to do that for this table because we want our primary key, based on our database diagram we did in an earlier project, to be a composite of both of these. So we're going to create a composite key. So you have to hold down the Shift key and select both at the same time. So when we select both at the same time, you can right-click, Set Primary. So now that you have these 2 set as primary, you'll be able to hit Control-S to save the table. You're going to get a dialog box that's going to ask you for the name of the table. You can see I've already created mine over here. It's going to be Patient Visits, and the other table will be Patient Visit Symptoms, which I'm going to show you here in just a second. So this is our Patient Visits table. Pause the video, create your primary keys, then come back and we'll create the other table. So our other table, I'm just going to show you what it looks like here. So here is my patient visit symptoms. It has the patient key and the visit date. These are also going to be primary keys. So we're going to do the same procedure we did before. You'll highlight both, right-click, Set Primary. I'm going to save mine by hitting Control-S. When you do that, it's going to ask you for the name of the table. And again, it's going to be patient visit symptoms, as you can see over here. So go ahead and do that, and then come back to the video. Next, we have to create our database diagram. Not create, but edit our database diagram. So you're going to click on Database Diagrams. Open up the database diagram we created previously. So here's my database diagram. Notice we don't have our other tables in the diagram, so we have to add those tables and create the relationships. So I'm going to right-click, and I'm going to click Add Table, and I'm just going to click Add for both of these tables. When I do that, you'll see them appear over here. But we're going to want to move these around so that it's a little bit easier to work with it in this diagram. So in my case, I've moved mine to the left of the patient dropped patients. If you've been following along, your diagram probably looks similar to this. So I moved mine over here to the left-hand side. All right, so now we have to create our relationship. So first, I'm going to relate patient to patient visits on the patient key. So I'm going to click and drag this field. So make sure your primary key table is set to patient and patient key, and then your foreign key table is patient visits, patient key. So they're both connected on the patient key field. I'm going to click OK. I'm going to click OK again, and it creates our relationship. We have to do the same thing between patient visits and patient visit symptoms. So again, I'm going to click and drag from patient visits to patient visit symptoms. Now, if you recall, we want to use two fields. So we have two fields that are the primary key in both of these tables. It's not enough for us to use just the patient key to join these two or to create that relationship, because symptoms only relate to a single visit, and the only thing that defines a visit uniquely is both the visit date and the patient key together. So we have to make sure that we select patient visit on both sides. The visit date on both sides of this relationship. So these would be connected based on those fields. So I'm going to click OK, and you should do the same. One thing we're going to want to do here, and we've done this before, but before you click OK here, I'm going to switch the enforce foreign key constraint. I'm going to switch that to a no. And the reason we're not going to enforce that is because this is going to be a one-to-one relationship, meaning that they both have to exist in each of these tables. But that causes an insert anomaly in the fact that if we try to insert a patient visit for which we don't have a symptom yet, it's not going to allow us to insert. And likewise, we can't insert a symptom unless we have a visit. So we have to turn off the enforcement of that foreign key constraint to allow us to insert one at a time. So set that to no, and you're going to click OK. It'll create the relationship, and you'll see that we have the key on both sides, meaning that it's a one-to-one relationship, which we've done before. We did that with dropped patient and group assignments. One thing also that we need to do here, one thing I want to show you, if you forgot to click that button, you could also right-click, go to Properties, and you could set that option over here as well. So if you forgot to do it, it's okay. You can do it over here later on. If you don't, when you right-click, if you don't have the option to show the properties, in some versions of Management Studio, if you just click on a relationship, this window will automatically appear on the right-hand side. And when you're done with this window, you can always close it in some versions of Management Studio. This is the first deliverable for our project. What I'd like you to do is we're going to take a screenshot of this. But before you take a screenshot, bring up your notepad in Windows, type your name, so that when you take the screenshot, we can do both. And the way you take a screenshot of both is you can use the screen snipping tool. If you're using VMware, you can use the screen snipping tool on the host, but really you can take a screenshot of the entire VM. If you're not using VMware and you're doing this on your regular computer, the screen snipping tool is a great tool to do that. I'll show you right now. When I click on the screen snipping tool down here at the bottom, and this is included with Microsoft Office, I click New. I draw a box around what I want to save, and it becomes an image, and I can save it. And this is going to be the first deliverable that you're going to submit with the project. All of these deliverables can be in one Word document. You don't have to submit them separately, although you can zip them up and submit them as a zip file as well. So when you've completed the database diagram, be sure to close it and make sure you save it when you close it if it asks you to save it. Next, we're going to discuss stored procedures, but before we do that, I'm going to demonstrate why it's important to use things like stored procedures for database security. To demonstrate this, I've created a simple application that works with our database, with our Westlake Database. So in this simple application, don't worry too much about all the code on here. I'll show you the salient parts, but here we just connect to a database. That's all this code is doing. It's connecting to my Westlake database, as you can see here. And once it connects, down here, it's first going to do a select from the patient table, and then it's going to start building a table in a web page. So this table is going to have a header that shows you all the columns that we're looking at, and I have a little spelling error here. I'll fix that. Then down here, it's going to iterate through all of those. This is a while loop that's going to iterate through all the rows that it finds in the database. It's going to output those rows into our table. And then it's going to output a form where we could add a new record to our database. So if somebody fills out this form and clicks Submit, that's going to post the data to this little web page, and it's going to dynamically construct an insert statement. So what happens here, this looks familiar, right? This is just a regular insert statement, just like we've been writing in class when we insert data to our database. But the fields or the values are being dynamically populated from the data that was posted from our user, from our web app. So these are all the variables that were posted into this web page, and it's going to dynamically create this statement. And for demonstrative purposes, I'm exporting that insert statement so you can see what it looks like, see how it was dynamically generated, and then it's going to execute that statement. So let's take a look at this example. So here's the web page for my little example. And here is that same database table in my database. So let me just refresh this so that they're the same. There we go. So here's my, my data that's in my web app. It matches the data that you see here in my actual database. And what I'm going to do is I'm going to add a record. So I'm going to add 1, 2, 3. It's going to be Brian C. Green. And there's my phone number. So I'm going to add this by clicking the little button on the end. It's going to post that data. So here's the information that got posted into the web page. And then this is the SQL statement that it generated. And you can see the values over here. So this is just like the SQL statement that we run, but this gets run from our web app. And likewise, if I come over here, I'm going to refresh this. And now you can see Brian Green in here. Now, let me demonstrate a SQL injection attack. Let's say I have a bad user that comes along and decides to insert a patient called bad, but for the phone number, they put something like this, right? So take a look at this code that's in here. Now I'm going to execute this. We're going to look at the insert statement, and then we're going to look at the results that we end up with. So I'm going to click the button to insert it. Now look what happened. My patients are all gone. Why did they get removed? Well, take a look at this statement up here. And just to make it clear, I'm going to copy this statement and I'm going to put it into SQL. And by the way, you'll notice that my patients are gone here as well. So here's the SQL statement. And just to make it easier to read, I'm going to add some carriage returns here. So it looks a little bit more like what we're used to. So this is the SQL statement. Now take a look. I've got the insert statement. This part makes sense, right? But then after that insert statement is complete, it's then going to run this delete from patient statement with no parameters, which means it deletes everything. Then I have 2 dashes, and then this is what was dynamically on the end of that statement. So all of this that you see here was done dynamically up to this point. The field that we inserted is from here to here, and then here's the output from our from the variable. So the dashes just make this a comment. If I didn't have those dashes, the statement would fail, and I'll show you. So if I run this, the statement fails because there's an extra quotation mark at the end. It doesn't know what to do with that. But if I make it a comment, it's going to ignore it. So it's going to ignore all that code. So it's pretty easy to do a SQL injection attack like this. I have to be in the right database, though, for this to work. There we go. All right, so that's basically how we can do a SQL injection attack. So to prevent that, there's various ways that we can prevent a SQL injection attack. One way is our application. So this application, which is very poorly written, it's very simple and very poorly written, I could try to catch all the possible ways that people would try to inject bad data into my database and try to inject commands into my database. So that's one option to do this. But in many cases, we don't want to rely on the database, or I'm sorry, the application developer to do that. And also layers in security is important, which you'll learn about in a security course. But the other way we can prevent this in our database is not allow people to insert data, and instead use stored procedures to insert the data on behalf of the user. So we're going to create a simple stored procedure that does that, allows you to insert data. So the stored procedure that first I'm going to show you how to create is going to be for the patient table, just to demonstrate the concept for you. So let me go back into my regular Westlake database I'm using for the lab here. So the easy way to do this, the way that your book shows you how to do this, you're going to right-click on Patient, Script Table, Insert To, because this is the statement that we want our stored procedure to run, is this insert statement. So now I've got the bare bones, the basic information to create this insert statement. So my first step in creating a stored procedure is to add the create procedure statement here. So now it's going to create the procedure, and I gave it a name. I called it USP_record patient. Now, the next thing is we have to have some variables. So I'm going to add my variables. Now, there's a couple different ways you can add the variables. You could just type them in, like I just did here. And by the way, I'm going to tab these over so it's easier to see them. You could just type them in. If you don't want to type each one individually, if you open up your patient column, you could click and drag these so that it automatically puts the column name in here for you instead of typing it. That way you avoid any mistyped column names. Notice that I put the @ symbol in front of all of these variable names. You have to have the @ symbol in front of a variable name. And also make sure that the data types here match the data types that you see for the columns for the actual table. We want to make sure that these data types are the same. So in mine, my patient key is nchar15, but if for some reason in yours it's nchar10, make sure you use the right data type. And then finally down here under values, this is just our placeholder. We have to put our actual values here for our column names. So I'm going to go ahead and put those in. Whoops. There we go. All right. So now, when I run this, when I execute this, it's going to create our stored procedure. It's going to have a variable for each one of our column names that we want to insert. Then the insert statement that we created, along with the variable names down here. So the variable names will get substituted with what was passed into this stored procedure. So let me go ahead and run that. I'm going to hit execute. All right, now I have an object already in my database called record patient because I've already created this stored procedure before. So I'm going to go down here to programmability. I'm going to refresh my list, and I'm going to delete this. Now that that procedure is removed, I can create it again, and it works. And if I come over here, store procedures, I can refresh, and there's record patient. Now you are going to have to create one. You do not have to create the record patient. I did that for demonstration purposes. The one that you do have to create is record patient symptoms and record patient visit. And you're going to use the same method that I used to create the record patient. So use the same method. So you're going to right click, do an insert to so that it creates the insert statement, add the create procedure portion up here at the top, and make sure you change the values to the variable names that you used up here. You don't necessarily have to use the column names as the variable names. Technically, you could use anything you want. Go ahead and pause the video and create those two stored procedures, and then I'm going to walk you through how to test them, and then we're going to actually insert some data with the stored procedures, but we're going to do it from a file that's provided to the lab. So once you have these stored procedures, if you want to insert data, so I'm going to test inserting a patient. So let me close this. So I'm going to go to, under programmability, stored procedures, and remember, you might have to click refresh since you just created these. I'm going to right click on my stored procedure. I'm going to click on execute stored procedure. That's going to bring up a dialog box where I can fill in some variables. So I've typed in some values over here. These are the values that are going to get inserted by my stored procedure. And when you click OK, you'll see over here that it actually runs the stored procedure. So now this is pretty complicated how it creates the stored procedure. In theory, you could have run the stored procedure. I'll show you sort of just the bare bones of what you would need to execute the stored procedure. So if all you typed was, let me get rid of this here on the top. If we only type this, it would actually work. And we don't need these ends on the front either. Technically, you could get rid of those ends. Although it's good to have that there. We didn't really talk about that in class, but that would be the proper form. But this is, so technically we could run the stored procedure just like this. So if I were to execute the statement as you see it here, so just exec, name of the stored procedure, all the variable names. I'm just going to go ahead and hit execute here. And it ran. And if I were to go to my patient table, I should see all these new patients I added. One of them I added with the, so this one, oh, wait a minute, here we go, down here at the bottom. So Sam Bob Jones I added by using the GUI, and then Jack Joe Smith I added by running it right from the UI. So we're going to use this to insert data into our database. So I'm going to go ahead and close this. So you will find that there is a file for this project. This is what the file looks like. You can double click on this file and it will open it in your Management Studio. So once you have it in Management Studio, it looks pretty much just what we just did. We have our execute statements to run these stored procedures that's going to insert some data. So if I just hit execute up here, it should run. You'll see down here one row affected because it inserted that data. Now here's the problem. If you look at these three statements here and I scroll down, mine failed. And if you're wondering why it failed, take a look at the error message. Could not find stored procedure, record patient symptoms. And if I look over here, I'm going to go look at my stored procedures. So I have a record patient symptoms and a record patient, but there's a USP on the front of both of those. So in the book, when they provided this sample, they forgot to put the USP underscore over here. Now for yours, you may have different names for your stored procedures than were used for the book. And if that were the case, you have two options. You can either remake your stored procedure or rename your stored procedure. So you could rename it by right-clicking on it and you can rename it. You could execute it again with a new name, but with an alter to, or you could just come in here and change the name of the procedure. So if you have a couple lines that you want to run alone, just like we've done before, you highlight the lines that you want to execute, click execute, and now we have our records. Once you have your data in your tables, you're going to test it by running a select statement, as you've seen I've done here. I'd like you to run statements similar to these, but replace your name or my name with your name, so it shows up as a column. So you're going to highlight these two, and then you're going to click on execute. And you're going to take a screenshot of this area here. You don't necessarily need to have these inserts, but you definitely want to have a screenshot including the select statements and the results of those select statements down here at the bottom. And they'll look just like mine. You'll have the same data since we both use the same file. And this will be the next deliverable. In addition, you're also going to include the code from your stored procedures. You don't need to take a screenshot. You can just copy and paste the code. So when you right-click on a stored procedure, you can click on Modify, and then you can copy and paste this code into your deliverable, into your document that you're going to turn in for the lab, along with this screenshot here. So we can see the stored procedure, and I'll be able to see your insert or your select statement showing the data that you inserted, and it should have your name in the first column. So pause the video, and when we come back, we're going to start looking at indexes. So here I've selected only the data from my patient visits table. And if you take a look at this, it's sort of ordered in a certain way, right? So we have our patient key and our visit date. And if you notice, all of the same patients are grouped together. So regardless of how I insert these records, they'll always be grouped together. I'll show you an example. So I'm going to run this stored procedure that's going to insert another record into my patient visit. Now take a look. This is patient number 1-24. So really, if it's going to be in the same order that we have down here, if I run this insert statement and then I do this select statement again, I should see that record inserted right here between the August 27th and September 7th records. So it should kind of get sandwiched right in between there with this new record. So let me run this. And now we're going to select from our table. And take a look at what happened. That record is in fact now sandwiched right in between. It went right where it's supposed to go. And notice I'm not doing an order by clause in here. Now I could add an order by, so I could put an order by and put some field name in here, like order by weight, for example. And if I order it by weight, it might be a little bit different as the weights fluctuate. But by default, it is going to order it a certain way. So what causes that to happen is indexes. And I'm going to describe a little bit about how these indexes work. We haven't really talked about indexes too much in class, so I'd like to kind of just talk about it a little bit. So take a look at this fake table that I've created here. This is just maybe a little directory, a little telephone directory. Now most of the time, if we have a telephone directory, the easiest way to store the records in our directory, if we're going to use it on paper, I know nobody uses phone books anymore. We all use, the internet and Google Voice and things like that to dial for us. But assuming it's, 1987 and we're still using a telephone book, if you're looking up a telephone number, the most convenient way to do that is by last name. Imagine a directory that looks like this one, where the names have no order to them. So in order to find a name in the phone book, I'd have to start leafing through every single page. Now in a small directory, like say one that you have at home, it's not that hard. You can probably get through all the pages in a few minutes. But think about a phone book that you get from the phone company that has 175,000 phone numbers in it. There's no way you're going to be able to go through 175,000 phone numbers to find the one number that you're looking for. So when we get a directory, we all know this, it's going to be in alphabetical order so that we can more easily look up those records. A database kind of works the same way. What we do is we pick a field in our database to be an index. how we're going to look up records. And almost every database table has at least one index. In fact, if you create a table with a primary key, that primary key is by default what's called a clustered index. And I'll show you how that works. So here I've reordered this data. I now have an index. This is a clustered index. And basically what a clustered index does for us is it's going to reorder the data, make sure the data is always in the correct order as it's stored in our database, in the table. So the physical storage of the file is going to be in the correct order. And if you think about it, that makes sense because when our database goes to look up records, when somebody does a query for a specific name, say in this directory, being in alphabetical order, it's more predictable. The database engine doesn't have to scan the full table looking for a record. It can go directly to the record that it needs. Now, one problem with this type of index is every time I insert a record, as we just saw in the demonstration, is that each time I insert a new record, it's going to have to move around these records. So for example, if I was going to insert Benjamin Franklin into these records, it has to go between Robert Morris and Alexander Hamilton, so in that second position. So I have to move all the records down. Oops, I went the wrong way here. So I have to move all the records down one position, then insert that record. So as you can guess, it takes a bit longer to do writes into your database table. So that is a clustered index. Now there's another type of index. If, let's say, we also want to be able to look up by city, and of course a telephone directory can't do this on paper, but we can do this in a database. You can create a non-clustered index where we create sort of a separate table. So it's a separate physical storage of those indexes, and the indexes have pointers to the rows that contain that data. So if we were doing a search by city, instead of doing a full table scan on the actual table, it can scan our non-clustered index that you see on the right-hand side, and it could use that to do the lookup. But notice that a non-clustered index does not affect the position of our records in our database table. So let's take a look at the indexes for patient visits. So I'm going to open up the patient visit table on the left-hand side over here, and we're going to open up indexes. So you can see this first index, PK underscore patient visits, which is a clustered index. So that's the kind that's going to reorder the records in our table. That's created automatically. If you right-click on it, you could certainly take a look at it, and you could edit it if you wanted to. But when you created the table and you made the primary key, it automatically created this clustered index. Now, the thing about indexes is you can only have one clustered index because clustered indexes reorder the physical storage of the data in the table. You can't have multiples of those because you can only store it physically one way. So additional indexes have to be non-clustered. So you can always have one clustered index, but all the additional indexes need to be non-clustered. So to create a new non-clustered index, I'm going to click New Index. I'm going to right-click and click New Index, New Non-Clustered Index. That's going to bring up a dialog similar to this one. So I'm going to give it a name. So I'm going to make an index for the depression level. So I'm going to call it IDX patient visit depression level, IDX, just so we remember that it's an index. We do have to add the column, so I'm going to click on Add. I'm going to select the column that I want to use, in this case, depression level. So now I'm going to have a index for depression level. So if you're frequently doing lookups for the depression level, it will use that non-clustered index, so it's going to be faster to look up records. So any fields that we know we're going to query on periodically, we definitely want to have an index to make it faster. Although it can impact the performance of our database because those indexes have to be maintained and they could become fragmented and you have to periodically do some maintenance to keep those indexes working. But in many cases, if you don't do an index, it's going to cause issues as well. So I'm going to click OK, and that's going to create our index. So now I have two indexes. So you're going to do this query again. Okay, so we're going to do this query another time. And in fact, you can also try inserting new records. And you're going to run this query and see if it changes anything in the output. So that's going to be the next deliverable. You're going to answer questions number 1, 2, and 3, which ask you, number 1, what does the order look like before we did the index? How is it ordered? And then we're going to create the index, and then you're going to talk about if this order changed and why or why not. And remember that we created a non-clustered index. So we have a clustered index, which was initially created when we created our table automatically. Then we created a non-clustered index. Did it affect the output of the table? In other words, did it affect the physical storage of the table? And why or why not? So next, we're going to create a trigger. So let me close this window. We'll start from scratch here. So if you take a look at our patient table, we have some columns here. But we're going to add a new column. We're going to add a column for the modify date. So every time somebody does an update on the patient table, we want to show that it was modified at that date and time. Give us a little bit of auditing. Since this is a little hospital database, they have to do some audit logging, so we're going to add a column to do that. So you're going to right-click on patient, and you're going to go to design, and you're going to add an additional column. So your column that you're adding is going to be date modified. The data type is going to be date, and we are going to have to allow nulls because it's going to be null when it's initially inserted. It's only going to get a date when somebody does an update. So we're going to allow nulls. Once you put that in, hit Control-S to save it. You're going to see the asterisk go away at the top, meaning that we've saved our table. So now that we have that new column, now we have to create a trigger that's going to populate that. So I'm going to come over here and hit refresh so you can see that column is now in our table. So there's the column. So now we're going to create a trigger. To create a trigger, you can come down here and you can right-click and do New Trigger. And this is the basic skeleton of what a trigger looks like. A lot of this stuff you don't need, so I'm going to delete this. Now here, you're going to put the trigger name. So in my case, my trigger name is going to be dbo.triggerPatientModified. So let me put that in. We're going to do this on the patient table. So I'm just going to click and drag patient in here. And we're going to do it after an update. So I'm going to get rid of all those other actions. So after an update happens, this trigger is going to run. Now the no count option you see here means that when this trigger runs, it's not going to show you the results of the trigger in the UI, which is kind of important. A lot of people get confused when they see multiple results show up. One row affected and then another row affected. So we're just going to leave that and set no count on. And then here's where we're going to put the trigger logic. So really what we're going to be doing is we're going to be updating the modify date. So let me add that here. So that makes sense. But what do we update it with? Well, we can't just put the date in here, right? Because the date has to change every time somebody does an insert. So it has to be dynamic. So luckily there is a function that SQL gives us, the getDate function. And basically getDate just gets the current date time. I'll show you how this works. I'm just going to write a little select statement down here. We'll do select getDate. And notice it just gives me the current date time. So getDate function just substitutes the current date time. Now I have to add a where clause. This is the part that you're going to do on your own. We only want to update this where the patient key has a certain value. You've got a couple different ways to do this. I'm going to tell you the way that I would do it is, well, here's the important thing. When you write this trigger, you want to make it so that if somebody is updating more than one record, it can do multiple records. So that's the first hint. Now, if you just make patient key equal to a certain value, it has to be a specific value. But instead, we want it to be in a range of values. And where are we going to get that range of values? Here's your second hint. It's there is a table, a sort of a virtual table in a trigger called inserted. And that inserted table contains all the columns. So we want to find the patient key where it's in the inserted table, where that patient key is in the inserted table. So you have to select the patient key from the inserted table. So use that hint and create this trigger. So do a select first from your patient table. And when you do a select, you're going to see all the records. Notice that our date modified is null on all of our records. Then you're going to write a simple update statement. So write an update statement that's going to update the patient table. You're going to run that update statement. You should see that it affects one row. So it should have updated the phone number, for example. You don't have to update the phone number. It can be anything. But just be sure that you put a where clause in. Then you're going to run your select statement again. And you should notice that you now have a date modified. So you can see in my case, I now have a date modified of 2016-0520. So I know when this was modified. So you're going to do the same thing and turn in for the deliverable, do a screen capture of what you see here. So it should have your select statement, the update statement, the results of the select statement. So you should see the results, because this is the last step here, showing the date modified, and be sure that you've done your select statement like me, where you have your name as student, comma, and then the asterisk. That way we can see your name in the first column. So go ahead and take a screenshot of that, and then we're going to move on to the last step in this project, which is executing some standard queries. Now, in addition to the previous screenshot that you took. Also include a copy of your trigger. You don't have to screenshot that. You could just copy and paste it into your deliverable document. But include that trigger as well. If you don't have the trigger on the screen, you'll just simply right-click on it and click Modify, and it'll bring the trigger up on the screen. Okay, so next we're going to create some views. I'm going to walk you through the first one just to show you the process. So in the first one, they want us to execute a query that retrieves the visit date and patient key for all patients that reported a depression level over 5 and turn that in. So here's what we're going to do. Since we know the records, or the fields rather, they're looking for is the visit date and the patient key, that's what we're looking to retrieve, and it has to be a depression level. The field that, or I'm sorry, the column that contains those, the table that contains all of those columns is going to be patient visits. So this is the one we're going to do the select statement. So I'm going to right-click, do script table as, select to, just so I don't have to write it from scratch. We don't need this stuff at the top. We really just need the select statement, just like this. Now, the only fields I need are the patient key, the visit date. I don't need any of this other stuff. So just those two fields. And then we also need a where clause. So we're going to put where. And the field they want in the where clause is going to be depression level. So I'm just going to click and drag depression level. And they want greater than 5. So this should show me all patients with a depression level greater than 5. And there we go. So these are the visits where the depression level was greater than 5 and the patient keys. What I'd like you to do, though, when you create these views is you're going to, just like we did before, you're going to put your name on the front. So I'm just going to do Brian as student, and then a comma, and then my next field. So now that's going to be in my field list. So if I execute that, I now see all 3. And finally, in order to make this a view, we're just going to put some code in here to make it a view. So once you get it working, to actually run it, you simply, or to create a view for that, you're just going to put create view, the name of the view. So you're going to give it a name. We're going to do 5 of them. So we're going to name them query 1, query 2, query 3, query 4, and query 5. So you're going to do that. And then you're going to execute that, and it creates the view. And then if you like, you could come over here and you could look at that view. So I'm going to go to views. There's query 1. I could right click and I could do select top 1000 rows. And there's my view. So what I'd like you to do is 2 things. For each one of the queries that you're going to do, you're going to do the query. So I'd like to see a screenshot of, so in the screenshot, you're going to submit 5 screen captures. Each screen capture is going to show the select statement that you ran. So you're going to execute that select statement. It's going to show the create view on the top, and it's going to show the results down here at the bottom. And it should include the student name. So you're going to have a select. You're always going to have the student name here at the top. And you can always add that after you're done creating your select statement. You're going to highlight just the select, execute it, show it down here, but you're going to show the create view, query 1, query 2, query 3, and so forth as up here at the top, which is going to help me know which question you're answering. So you're going to do this for each one of those 5. So each one of these queries that you execute is going to require some of the skills that you learned in the previous projects. Mostly project number 6 and 7. So most of this is going to go back to what you've done in project 6 and 7. And you should be able to use those as a guide for the other 4 queries that you're going to do to create the other 4 views. And as I said, for each one, you're going to include the screenshot as I've shown you here. If you have any questions, let me know. Good luck. Thank you for watching.